Circle problems on the SAT really come in two flavors. There's these, which you've definitely seen in Module 1. Basically, plug in the formula and solve it. I consider these free points. And then there's challenging ones, where you'll likely see them in your Module 2 if you do well in Module 1. And that's what we're going to focus on today. 3 super challenging SAT circle problems. Let's jump in. Okay, for the first problem, we're being given the graph of a circle, right? X squared plus X plus Y squared plus Y is equal to 199 over 2. We're told the center is at H comma K, and we're asked to find the value of H plus K. Okay, so what are we actually looking for? We're looking for the center, and not just the center, we're going to be summing the center's coordinates, right? So we have to find the center of the circle. There's multiple ways to do this. You can complete the square and do it algebraically, which is a little bit hairy, or you can use Desmos, my favorite way. So I'm actually going to show you guys how you leverage Desmos to solve this way, way faster than you can algebraically. So what do we actually plug into Desmos? Just the equation that you're given, x squared plus x plus y squared plus y is equal to 199 over 2. Desmos does some neat things. The first thing it's going to do is going to give us the points where this circle crosses the x and y axis. So if you tap on the circumference of the circle, you'll see those points appear, these little gray dots in this case. You'll actually also find that there's an extra 2 points that it gives us. These are going to be the points on the diameter of the circle. Now, what do we know about the diameter of the circle? The diameter of the circle always goes through the center. So this is going to be really helpful for us. If I have the points on the diameter, which I'm going to label for myself, negative 0.5 times 0.5 comma 9.5, and the one down below on the other side is negative 0.5 comma negative 10.5. So those are my 2 points on the diameter. So what do I actually know immediately? Well, if I draw a straight line through this diameter, I know my center is going to be on this line. Well, that means the x coordinate will have to be negative 0.5, right? Because both of these points have the same x coordinate at negative 0.5. So now all I have to actually find is just my y coordinate for my center, right? And my y coordinate is going to be exactly equidistant between these two y coordinates. So 9.5 and negative 10.5, the center of those 2 points is going to be my y coordinate. Think about this logically. Don't think about formulas or the midpoint formula. How do I find the distance of this line? Well, I'm going to go from 0. To get to 9.5, I have to move 9.5 units up. To get from 0 to negative 10.5, I'm moving 10.5 units down. So in total, I'm moving 9.5 plus 10.5 units, which is 20. And I'm trying to find the center, so 20 divided by 2 is 10. So what that actually means is if I move 10 units either up from this point or 10 units down from this point, I will find my center. So let's just move 10 units up from negative 10.5. Well, if I'm moving 10 units up from negative 10.5, I'm actually going to be at negative 0.5. So my y coordinate is also negative 0.5. Am I done? No, I need to find the sum of these. Well, what's negative a half plus negative a half? It's just negative 1. So that's it. What you have to know is that Desmos does give you the 2 points on the diameter. As soon as you know that, it's much easier to back into this question. Completing the square is much hairier. It's very doable, but much hairier for this problem. So give it a shot, but definitely leverage Desmos if it's faster. Okay, so our second problem is a circle in the xy plane has a center at negative 1, 1. Line T is tangent to the circle at 0.5, negative 4. Which of the following points also lies on line T? So my answer choices are coordinates, and I'm supposed to figure out which of the coordinates are on the tangent line. Well, let's draw this out for ourselves. We have negative 1, 1 as our center, and then 5, negative 4 is a point on the circle and also a point on the tangent line. So let's draw out my circle. And what I quickly realize is if I connect these 2 points, that is my radius. Why? Because any point on the circle connected back to the center is always your radius. So that's my radius. And then if I draw out line T going through 5, negative 4, a tangent will only cross this circle or only touch the circle in 1 point. So if we draw that out for ourselves, what do we know? We know that a tangent is always perpendicular to the radius of a circle. So this is the fact you need to know in order to answer this question. Now, if you know coordinate geometry, you know that 2 lines are perpendicular if they have a negative reciprocal slope. So if I find the slope of the radius, I could easily find the slope of my line. And that's my goal because I'm trying to get the equation of this green line in order to see if any of those points are actually on that line, right? So let's find the radius the slope of the radius, right? So how do we find the slope? Well, that's your slope formula, y2 minus y1 over x2 minus x1. So in this case, we get -4 minus 1 over 5 minus -1. That simplifies down to -5 over 6. Great. How do I get the negative reciprocal? You're going to flip your slope, and then you're going to negate it. So -5 over 6 flipped becomes -6 over 5, and then negated, well, negating a negative becomes a positive. You get a positive 6 over 5. So my slope for the tangent line is 6 over 5. Now, how do I actually create the equation of the tangent line? Well, if I have the slope and I have a point on the line, which we know is 5, -4, I can actually build the equation. And how do I do that? That's another formula. It's the point slope formula. And that's y minus y1 is equal to m times x minus x1, right? I have x1, I have y1. That's my point, 5 and -4. And then my slope is 6 over 5. So if I plug those in, I get y minus -4 is equal to 6 over 5, x minus 5. Y minus -4 is the same as y plus 4 equals 6 over 5 times x minus 5. Now I'm going to go to Desmos, and I'm actually going to plot this so I can see it on the graph. And all I then have to do is actually see which of these points lie on the circle. You can write all the coordinates in, or you can use a little bit of mental math and see visually that, well, choice A cannot be on this line, right? 0, 6, 5 is going to be right way before where this crosses the x-axis, which is at 8.3, right? So you can kind of eliminate some to save some time here, but you can plug all of them in, and you quickly see that the only answer choice that is actually on the line is answer choice C. So the important thing to remember here is that a tangent always crosses the circle in one point, so they touch on one point, and it will always be perpendicular to the radius. If you know that, 9 times out of 10, they'll test this using slopes. So know your negative reciprocals for perpendicular slopes. Okay, this last one is my favorite one. So we're being given the circle has a center at O. The length of arc ADC is 5 pi. X is equal to 100. What is the length of arc ABC? So let's map this out on our diagram a little bit. So ADC, this minor arc, is 5 pi with a corresponding angle of 100 degrees. And now we're looking for this major arc ABC, so in blue. So the first thing I'm going to think about is, can I actually get this angle here? Yes, I can, right? Because I know a circle has 360 degrees. So if this is 100 degrees, I can just subtract that from 360 to get this angle here, right? So that would be 260 degrees. So now I could actually set up a ratio, right? 100 to 5 pi, 260 to x, right? So how do we write that out? So it's going to be 100, our degrees on one side, so 100 over 260 is the same as 5 pi over x. If I simplify 100 over 260, I know that's the same as 5 over 13, right? If we divide by 10, then divide by 2 again, is equal to 5 pi over x. Now I cross multiply, I get 5x equals 13 times 5 pi. Divided by 5 on both sides, I get x is equal to 13 pi. And x is my major arc, so answer choice B, 13 pi. Trick here is just to understand how to utilize the information that they're giving you and set up the ratio properly. That's all I have for you guys. I hope that was really helpful. If you have any requests for future video topics, just comment down below and subscribe. There'll be plenty of more SAT videos. I'm pumped to be part of your studying journey, so let's do this.